using MATLAB. So this paper contains two parts, part A numerical methods and part B MATLAB programming. And first unit in part A, numerical solutions of algebraic and transcendental equations. Yesterday we discussed about the definitions of algebraic and transcendental equations. Now what is meant by algebraic equation? What is meant by algebraic equation? Anyone? What is meant by algebraic equation? What is meant by algebraic equation? An equation
containing only algebra.
An equation, I will write a0 plus a1x plus a2x square plus and so on an x power n equals to 0, or you may write starting from nth degree term or constant term. Now this equation is called an equation a0 plus a1x plus a2x square plus and so on an x power n equals to 0 is called an algebraic equation. Okay. Now simply we can write it as fx equals to 0. F of x equals to 0. What is f of x? F of x is the left hand side term. F of x equals to a n x power n plus a n minus 1 x power n minus 1 plus and so on a naught a. Now this is called an algebraic equation. But the example, give one example of an algebraic equation. This is an algebraic equation. First example is this one. Now another example is 0. This is another equation, another algebraic equation. Now if you observe, what is the degree of the first equation? Anyone responding?
3.
3, sir. 3.
3.
Degree is 3. How many roots are there? How many roots are there? So if the degree is 3, degree is nothing but the highest power of the equation. If the degree is 3, this equation has exactly 3 roots.
3 roots.
What are the 3 roots? Suppose first root is complex root. Just assume complex root. Now second root must be complex conjugate. Complex conjugate. Suppose if it is a plus ba form, now second must be a minus ba. Now third root must be a real root. Suppose first root is real root, second root is also real root, third one is also real root. Here only 2 possibilities are there. All are real roots or 2 complex root and 1 root. So if the degree of an algebraic equation is odd number, then this equation has at least 1 real root. This is very, very important point. So this equation has, second equation has total 21 roots. Among 21 roots, this equation has at least 1 real root. This equation has at least 1 real root. Maybe more than 1 real root. At least this equation has at least 1 real root. Now coming to the another equation. Suppose if you take x power 4 plus 4x plus 4 equals to 0. Just assume. So if the degree is 4, then what are the possibilities? What are the possibilities? First one is complex root, second one is complex root, third one is complex root, fourth one is also complex root. This is the first permutation. Suppose first root is complex root, second root is another root is complex root, third one is real root, fourth root must be real root. Suppose first root is real root, second root is real root, third root is the real root, fourth root is, what are the possibilities? All are complex, all are real, or two real, two complex. If we observe in this case, this case, this equation has one real root, and this case also okay. But in this situation, it has no real. Degree of an algebraic equation is an even number, then what are the possibilities of root? This equation has four roots. What are the possibilities? All are complex roots, all are real roots, two real and two complex. In each and every case, if you observe the case, in this case, the given equation has at least one real root, and also in this case also the given equation has at least one real root. But in this situation, all are complex roots case, this equation has no real root. So in our subject, we will find at least one real root. Find at least one real root using any computational method. This is our concept. So suppose if the degree is if the degree of an algebraic equation is odd number, there is no guarantee to find a real root. That's why usually we will take odd powers only, odd powered equations only. Degree of an algebraic equation is odd number. Okay, up to this clear? Up to this clear?
Yes, sir.
Yes, sir.
Now coming to transcendental equation. Already we discussed it in the last class. What about the transcendental equation? This is also an equation, but this equation contains logarithmic functions, trigonometric functions, exponential functions, transcendental equations. Transcendental equation. Now what is the example? What is the example? One example is x sin x cos x equals to 0 is the one of the example. E power x plus sin x equals to 0 is another example. And another example is x log x base 10 or e, then no problem, equals to 1.2. So these are all examples of transcendental equation. But in this situation, just we will find a real root of the equation. So we don't know how many roots are there. We don't know how many roots are there, this equation, but we will find at least one real root if it exists. Now this is nothing but transcendental equation. This is yesterday's concept. Now coming to geometrical representation of again I will explain. Geometrical representation of a root. Listen carefully. We will apply this concept for computational methods. Now listen. What is the geometrical representation? Listen carefully. Then we will discuss our method. Geometrical representation. Now listen carefully. Suppose an equation is given. Fx equals to 0 is an equation. Let fx equals to 0 be the given equation. Fine. For example, yesterday's example, x square minus 4 equals to 0. So assume in this problem, fx equals to x square minus 4. Now coming to y equals to fx. Y equals to fx is nothing but be a curve. Now draw the curve y equals to fx curve. Now what is the procedure? This is x, this is y. So y equals to x square minus 4. For different values of x, y, z, suppose if you put x equals to 0, what happened? Now this is minus 4. Now this is look like this curve, y equals to fx curve. Now root of the given equation is nothing but point of intersection of the curve and x-axis. What is the region? Now listen. What is the reason? The point of intersection is nothing but the root of the equation. What is the reason? If you put x equals to 2, what happens? X equals to 2, this becomes 0. So nothing but y equals to 0. When x equals to 2, y equals to 0. When x equals to 2, y becomes 0. When x equals to 2, y becomes 0 is nothing but fx equals to 0. When x equals to 2, fx equals to 0, y equals to 0 is nothing but the equation. So 2 satisfies this equation. In the similar way, f of minus 2 is also 0. Minus 2 comma 0 is another point of intersection. Okay. Now, what is the meaning? When x equals to 2, f of minus 2 is 0. So minus 2 is also a root, 2 is also a root. So these points of intersections are nothing but roots of the equation. Roots of the equation. Now we are using now we are using this concept for finding the roots of the given algebraic or transcendental equations. This is very simple concept. Now coming to intermediate value theorem. Up to this yesterday's concept. Intermediate value theorem. Now note down intermediate value theorem. This theorem for finding the location of the root. For finding the location of the root, we will use intermediate value theorem. First, I will explain the statement. Then we will apply the theorem. Let f from closed interval a b to r be a function, be a continuous function such that f of a comma f of b have the opposite signs, then there exists some c belongs to open interval ab such that f of c equals to 0. I will explain this statement. Now note down this statement. And now what is the statement? Now listen, I will explain with diagram. Now listen carefully. Now this is x-axis and y-axis. Suppose we have a curve like our previous example. Y equals to fx is the curve. Okay. Now starting point is, I will take this point as A, this point as B. This point I will write with another color. Now, okay. So now I will take A on the x-axis, B on x-axis. Okay. Now 2 points. At the point, now observe this point, A comma f of A. Now at this point B, okay, I will take B here, near to this one. This is B. The corresponding point is B comma f of B. Now listen carefully. Now observe. At this point A comma f of A. What is f of A? Whether it is positive or negative. Respond. Emma, anybody respond? Whether it is positive or negative.
Negative.
Negative, very good. Now f of b,
Positive.
Positive.
in this situation,
Positive.
f of a is
Positive.
negative, f of b is positive.
Positive.
Now f of a comma f of b having opposite signs. Having opposite signs, and also from A to B, our function is continuous, no break between A to B, there is no breaks. Okay, first statement is fulfilled. F is continuous from A to B, from the point A to B, and f of A and f of B having the opposite signs. In this situation, in this example, f of A is negative, f of B is positive. Then what happened? There exists some C between A and B. Between A and B, what is the condition? F of C equals to 0. C satisfies this equation. The curve intersects the x-axis because f of A is negative, f of B is positive. Our curve definitely intersects the x-axis at a point C. Now the C is called the root of the equation. I will repeat again. Listen carefully. Intermediate value theorem. What is intermediate value theorem? The given function is continuous from a point A to B, and f of A comma f of B having an opposite signs. Then what happened? From A to B, our function is continuous. At A, function value is negative. At B, function value is positive. So definitely our curve intersects the x-axis. This point is nothing but, point C is nothing but the root of the equation. So this is first example. Suppose if you take another example like this. This is A, I will take this is B. At this point A comma f of A. This is second point. At this point B comma f of B. So in this situation, f of A is positive, f of B is negative, having opposite signs. Then what happened? There exists at least one C between A and B satisfying our equation. Nothing but C is the root of the equation. So now we are using geometrically. So this theorem is called an intermediate value theorem. Not all this theorem, most important theorem, we will use the same theorem for finding the location of the root. Okay. Now example. First example. Find the, first we will find the location, then we will find the roots. Find the location of the roots of a root. A is enough. A root of the equation x cubed minus 3x plus 5 equals to 0. Now listen carefully. First we will find the location, then we will find the roots using a suitable or any method, any computational method. Now first assume fx equals to x cubed minus 3x plus 5. అందరి దగ్గర క్యాలిక్యులేటర్స్ ఉన్నాయా? Without calculator, we can't do anything in unit number 1, 2, 3. Scientific calculator is enough. So take the Casio calculator 991 ms or ES calculator. 990 Casio 991 ms or 991 ES calculator is required for solving our numerical methods or computational methods. Okay. If you have a calculator, I will explain the shortcut method, but at this moment I will explain directly. Now first put x equals to 0. What happened? X equals to 0, you will get 5 positive.
Right.
Okay. X equals to minus 1. You may take any number, then no problem. X equals to minus 1, then what happened? Minus 1, minus 3, that's 5. So 1 again positive. F of minus 2. F of minus 2 minus 8 plus 6 plus 5.
Sir,
So then
f
what
of
happened?
minus, sir, f of
Okay, this is
minus 1
also
plus
okay, then no
7, sir.
problem. 7. Which is positive, then no problem. I will explain. Wait. Now I am using calculator. Okay. That's 5. I will explain the shortcut method, shortcut tricks using calculator. So tomorrow I will explain the method with the help of calculator, how to find with the help of calculator. Minus 2 is also, if you put minus 2, you will get 3, again positive. F of minus 3. If you put x equals to minus 3, what happened? Minus 13, negative. Whenever you will get an alternatively positive and negative or a negative and positive, then what do you say? You by intermediate value theorem, what do you say? By intermediate value theorem, the given equation has a real root between which number? Minus 2 and minus 3. So we can find the root between minus 2 and minus 3. This is very, very important. So for each and every problem, we will apply this technique. So what is the procedure? Now assume fx equals to the given equation. Put x equals to 0, minus 1, minus 2, minus 3, or 0, 1, 2, 3, and so on. Find out a pair which is positive and negative. Whenever you will get positive and negative, then the corresponding root lies between, then the corresponding root or the required root lies between the corresponding two numbers minus 2 and minus 3. This is very simple example. Okay, I will explain with another example. Same fx equals to, I will take another, so equation, I will take equation x cubed minus 3x, okay, minus 5 equals to 0. Assume fx equals to x cubed minus 3x minus 5. Put x equals to 0, what happened? Minus 5, first negative. Now, f of minus 1, what happened? F of minus 1 or 1, then no problem. Put x equals to 1.
Minus 7.
Put x equals to 1. Take the numbers. If you put x equals to 1, minus 7. If you put x equals to 2, f of 2, minus 3. F of 3, 13. F of 3, 13. So this is negative, this is positive. Whenever you will get a pair of alternatively negative and positive or positive and negative, then the required root lies between the corresponding two numbers. The required root lies between 2 and 3 only. Okay? Or understand the method? Very easy method for finding the location of the roots. Okay. Now I will take another example, not our routine problem. X sin x plus cos x equals to 0. So it is very difficult to find orally. Assume fx equals to x sin x plus cos x. Now very, very important point. If the given equation contains trigonometric functions, now change the mode into radians. Now change the mode into the radians, not default our calculator in degrees mode. Now change the mode into the radians, then only find the values. Now put x equals to 0. Again, same procedure. Put x equals to 0, x equals to 1 or 2, then no problem. Now type the equation in our calculator. Tomorrow I will explain the methodology, how to find the roots. Okay, take the calculator, scientific calculator. Now put x equals to 0, directly you will get 1. If you put x equals to 1, what happened? 1.3817. If you put x equals to 2, f of 2, 1.4024. X equals to 3, f of 3, minus 0.5666. So first value is positive. Now this value is negative. Then what do you say? What is our conclusion? The given equation has at least one real root between 2 and 3 only. Between 2 and 3, one of the real root. This equation may have more than one real root, but one of the real root lies between 2 and 3 only. Suppose if you take a logarithmic function or any function, same procedure. What is the procedure? First, assume fx equals to the given equation, whatever it may be, 7x plus 9. Now put x equals to 0, 1, 2, 3, and so on. Now just observe. If all are positive, if you increase, suppose if you put x equals to 0 in this problem, 9, next 17, and the next again you will all are positive. If you put x value is positive, definitely this must be positive, this must be positive, positive, positive. So now go to negative values, minus 1, minus 2, minus 3, and so on. Now definitely you can find a pair of negative positive or positive negative, opposite signs, negative positive or positive negative. Then stop the procedure. Then conclusion is the given root has at least one root lies between the corresponding numbers, minus 2, minus 3, or depending on the given question. In this situation, anyone try it? Now tell me the location. Anyone using calculator? Anyone? Tell me the location.
Lies between -1 and -2, sir. Okay.
Minus 1?
And -2.
At minus 1, 1. At minus 1, 1. Or at minus 2, minus 13.
13.
Okay. Okay. First one is positive. Second one is negative. Then what do you say? The required root lies between -1 and -2. Okay. This is very simple method. Okay. Again, we will apply the same technique for each and every problem in this unit. Okay. Now coming to bisection method. This is the first method. Bisection method. Bisection method. Now what is the method? Very simple. Method is very simple. Let fx equals to 0, 0 with a given equation, and the required root lies between nothing but location, lies between A and B. Then x equals to A plus B by 2. Now this is the formula. Bisection formula is nothing but midpoint formula. Usually we will call it as x3. x3 equals to A plus B by 2. Now this is a simple method, and formula is also very simple. Then I will explain the method geometrically. Then we will apply the method for finding the roots. So up to this clear? Bisection method, fx equals to 0 is the given equation, and A and B are the boundaries of the roots, nothing but the location of the roots. Then find x3 using the formula A plus B by 2. Already we discussed it in the earlier class. Now listen carefully. I will explain with geometrically x-axis and y-axis. Okay, right. Okay. Now this is the given curve y equals to fx. Listen carefully. Listen carefully. Yesterday we discussed it with Lendi College. Where is Lendi College? What is the procedure? Where is Lendi College? Now observe. This is Lendi College. Where is Lendi? So between Visakhapatnam and Vijayanagaram. Vijayanagaram. Now first find the midpoint of these two. Suppose if the midpoint is okay. If the midpoint, so for example, this is the midpoint, Tagarapolsa. Then this is the first initially x, call it as x1 and x2. This is the midpoint of these two, x3. Now our college lies between these two, x2 and x3. Now again find the midpoint of these two, nothing but x4. Now again find the midpoint of x3 and x4, you will get x5. Now again observe the Lendi lies between x3 and x5. Again find the midpoint of this one, x6. Now coming to x3 and x6, midpoint is this one, x7. Now again find the midpoint of these two, some say x power x8. And again find the midpoint, again find the midpoint. Finally, we will reach the Lendi College. This is the methodology, nothing but bisection method. This is nothing but bisection. Bisection is nothing but the midpoint. Are you understand? Anyone?
Yes, sir.
Yes, sir.
Most of the students are not attentive. Now I am observing. Okay. This is a simple example, just wanted only for understanding. In a similar way, now coming to our problem, y equals to fx problem. Y equals to fx. Suppose first find the location. The root lies between a and b. First, initially, we call it as x1. This is x2. So, using intermediate value theorem, find the location. So, location, the required root lies between a and b. So, first to find the midpoint of x1 and x2, simply call it as x3. This is x3. Now, again, now observe, where is our root? This is nothing but the point of intersection. Where is the point of intersection between x2 and x3? So again find the midpoint of these two. Midpoint of these two. So I will find the midpoint. This is x4. Now the root lies between these two numbers. So again find the midpoint of these two. This is x5. Now again find the midpoint of these two. This is x6. Again find the midpoint of these two. This one. Again find the midpoint of these two. This one. So finally, after some time, we will reach our point of intersection. This method is called bisection method. So bisecting is nothing but the midpoint, nothing but a plus b by 2. Up to this clear? Anybody?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
If you understand geometrically, then it is very easy. Okay, now coming to problems. How to apply the problem. Okay, first question. First question using bisection method. Find, not just Narama.
Yes, sir. Not just now.
Find a real root. Find a real root of the equation x cube plus 7x minus 9 equals to 0 using bisection method bisection method with 3 decimal points. Okay, so take only up to 3 decimal points, no need to take more, because this is first question. Okay, so find a real root. Now observe very well, this equation has 3 roots, so this equation has at least one real root. Just find out. Suppose if all the roots are real root, yeah, okay, then we can find the 3 roots using the same method. Otherwise, at least find one real root using bisection method. First, what is the first step? Step 1. What is the step 1? Let fx equals to the given equation. What is the step 1? Assume fx equals to the given expression. Whether it is algebraic or transcendental, same procedure. Now, what is the next step? Finding the location. Using intermediate value theorem. No need to write, just only for understanding. Finding the location of the root using intermediate value theorem. Now, what is the procedure? Put x equals to 0, minus 9, negative. X equals to 1, 1 plus 7 minus 9, minus 1. Again. X equals to 8 plus 14 minus 9, 22. 30. Positive. The required root, conclusion, what is the conclusion for this step? The required root lies between 1 and 2. The corresponding points are 1 and 2. Now this is up to location. After finding the location, now we are applying bisection method. What is the formula? Bisection method formula: x3 equals to a plus b by 2. Okay, I will explain with tabular form instead of writing all the terms. Okay, now listen carefully. Tomorrow I will explain with your calculator how to use the calculator. Okay. Now, okay, I will close the table. Okay. Then no problem. Okay, now listen. First iteration, I will write here iteration number, nothing but step. Iteration, I will take it as IT, iteration number. This is x1, x2, x equals to x1 plus x2 by 2, bisection method formula. Okay. Then I will take f of x, then remarks. First iteration, number 1. The required root lies between, what is the numbers? 1 and 2. Okay, fine. At 1 and 2. x1 equals to 1, x2 equals to 2. At 1, what is the fx value, negative or positive? At 1, f of 1 equals to negative. Okay, I will write negative, n negative here, just for understanding. At 2, positive. Now find the mean of these two. X1 plus 2 equals to 1.5 with 3 decimals, 1.500. Now substitute 1.5 in our function. What is the given function? What is the given function? I will write here. Fx equals to x cube plus 7x plus 9, I think. Minus 9, okay, minus 9. Minus 9. Okay, listen. If we substitute 1.5 in this equation, then what happened? X cube plus 7x minus 9. If you put x equals to 1.5, then what happened? 4.875. Whether it is positive or negative? Positive. Now listen, I will explain with the diagram. So initially this is A, this is B. Nothing but x1, this is x2. At x1, negative. At x2, positive. Now we are finding x3. At x3, negative or positive? Positive. By intermediate value theorem, then tell me the location. Anybody? X3 is positive, 4.8 something. Then what do you say? The required root lies between
x3 and x2.
x1 and x3, because alternatively negative, positive, or this one negative, this is positive. Then the root lies between x1 and x3. Okay, then what do you say? The required root lies between which number? At 1.5, this is positive, this is also positive. Now 1 and 1.5. I understand. This is first step. Okay, now coming to very, very important. If fx is positive, now listen, fx is positive, write the x value in positive column, 1.5. If fx is positive, write the x value in positive column. Now second value is same. Now this is nothing but the required root lies between 1 and 1.5. Okay, again find the mean of these two. Again find the mean of these two. A plus, what is the mean of these two? 1.
1.25.
1.5.
1.25.
So 1.250. Very good. Okay, very good. Now,
Sir, the x3 equals to x1 plus x2 by 2.
now okay, leave it. Now, suppose if you again replace x1 is 1, x2 is 1.5. Suppose if you write the programming, then what is the procedure? Again, we are assigning the same number. We are using for loop. We will discuss later. Again, we are assigning x3 as x2. Okay. After finding x3, x2 becomes x3. Okay. x3 equals to 1.5. Again, we can write the same formula, we can run the for loop again. Okay. Now substitute. Some disturbance is there. Now, after finding the x value, now substitute x value in fx. Then what happened? X value is 1.250.
1.70.
1 minute. 1.250.
170.75.
1.703 positive. Now, what is the procedure? If it is positive, write the x value in positive column. Then second value is 3. This is third iteration. Then what is our conclusion here? What is the conclusion? The required root lies between 1 and 1.250. Okay. Now again, find the mean of these two. First value is 1. Second value is 1.250. 1.125. Now substitute 1.125 in the function. Then what happen? You will get 0.299, again positive. Whenever this is positive, write 1.125 in positive column. Suppose if it is negative, write in the negative column. Second value is same. Now again find the mean of these two. 1 and 1.125. So your value is 1.063. Now substitute this value in the function value. You will get minus 0.335 negative. Then what do you say? This is negative. Write the x value in negative column. Second value, other value is same. Now what is our conclusion here? The root lies between 1.063 and 1.125. Now we are reaching. Okay, again. Now find the mean of these two. First value is 1.063. Second value is 1.125. Mean value is 1.094. Okay, now substitute this value in the function value. Very easy, don't worry. If it is first question, it will look like some confusion is there, but very easy. Minus 0.033, again negative. Then what do you say? This is negative. Then what do you say? Write the x value in negative column, 1.094 and 1.125. Again find the mean of these two. 1.094 and 1.125 is nothing but 1.110. Now substitute this value in the function. You will get 0.132. So now positive, write the x value in positive column. Now second value is 1.094. Again find the mean of these two. So repeat the same procedure until x is repeated. Then stop the procedure. But usually in our examinations, find up to 4th iteration. No need to find all the iterations, don't worry. But in computer programming, if x is repeated or fx is, now listen, this is called stopping criteria for programming. If x is repeated or fx equals to 0.0001 less than 0.001 less than or equal to 0.001, then stop the for loop. We will discuss in our programming. Okay, so repeat the same procedure up to x value is repeated or fx is less than 0.001, then only you will get the 3 decimal accuracy. Okay, tomorrow we will discuss another problem with the bisection method. Again, we will discuss again. Don't worry, but very easy. So with our calculator, we can easily find the value. Otherwise, it will take more time. So tomorrow, bring your calculator. We will discuss with our calculator. Without calculator, you can't do anything in our class. Okay, particularly in first 3 units. For the remaining 2 units, MATLAB is required. Okay, we will discuss how to use the MATLAB, how to get the MATLAB software. We will discuss later. Okay, so today I will stop here.